Okay, here in packet 2, we are going to get started with the relations and functions, and then we'll move into slope. So topic number 1 talks about what is a relation, what is the domain, the range, and then checking to see if something is or is not a function. So your definitions are, a relation is a set of ordered pairs. Now don't forget ordered pairs are just x and y, right? That's an ordered pair. The domain is the set of x values, and the range is the set of y values. A function is a relation with no repeating x values, and to check if a graph is a function, we use the vertical line test. So let's go back through that. It's been a while since we've looked at these. So I'm going to look here at number 1. First up, I know I have a table. Now the domain is the x values, so I am going to list out the x values in order, least to greatest, no repeats. So I'm going to use braces. Remember, a set of values, and yes, braces are impossible to draw, but that is a brace. X values, so if I go across from x, I have -1, 2, 5, -1. Order them least to greatest, so -1, 2, and 5 is my domain. End brace. That's my set. Range, on the other hand, is the y values. Again, inside braces, least to greatest, no repeats. My y values are across the bottom, so we'll go 0, 2, 3, and then 7, and we'll end with another brace, so a closing brace. Now, is this a function? Now, functions are all about the x values. We do not want the x value or the input to have two different y values or an output. So I look at my x's and I notice that I had a -1 and a -1. So the -1 is the input. When I input -1, I get two different y values. So no, this is not a function. It's not a function, and the reason being is when I input -1, my output is both 2 and 7. I can only have one output for every input. All right, number 2, I've been given what we call a discrete, if you remember that word, discrete graph. And it's discrete because it's not connected. We just have coordinates or points, I guess we could call them, right? Plotted on a graph. So this is a discrete graph. I still want the domain, so I just want all of the x values, and then I'm going to want the range, all of the y values. So you can do this a couple different ways. You could just start with the far left and work your way to the right for x, and bottom, top for y. You could list out all of the ordered pairs and then put them into a domain and range. That's sort of up to you. I'm just going to start at the left here. The first x is -3, then I go -2, -1, so I'm going to list those. -3, -2, -1. I'm going to keep going. Over here I have another coordinate here at 1, and then I have one at 4. So that's my domain. I'm going to go ahead and put braces on both sides. Okay, so next I'm going to look at the range. Start with my brace. This just tells me I have a set of values that need to be put together. I'm going to start all the way at the bottom and work my way up because I want to go least to greatest. So my coordinate down here, let me figure out where this is. This is 1, 2, 3, 4, 5. Now let me try that again. 1, 2, 3, 4. Yeah, that looks like -5 to me, right? So let's go ahead and say that's -5. Then I'm going to come up here. This is at -1. This for my y value would be 0. And my y value here would be 2. We're going to put braces on that. And we're going to look to see if this is a function, yes or no. So again, it's all about the x values. So I'm going to look to see all of my x values have different y values. There's nothing on top of each other. They're not aligned vertically. So that tells me that yes, this is a function. So number 3 here, If we take a look at this, I want to remind you that this is called a mapping. This is called a mapping. And this is really, again, just a set of ordered pairs shown differently. If I was to rewrite this, this would be 4, 2, 4, 5, 6, -1, and 7, 3. So the arrows connect X and Y. So if I wanted to, I could write these out to the side, just so I can think about what am I seeing. Make sure we understand how these are set up and what they mean. And then we're going to go through, we're going to list the domain again. So I want all of the X values in order, least to greatest. Again, no repeats. And really, they've already done that for me. 4, 6, 7. I'm going to look at the range. I'm going to put that. Again, at the Y values, the difference here is they didn't put them in order from least to greatest, and we are going to. They won't always, but it is good practice. So we're going to, as mathematicians, try to be as precise and as clean with our work as we can be. So -1, 2, 3, 5. And I want to know if this is a function. And again, the function is I can't have the X value have two different outputs. So I cannot have an input with two outputs. So the answer here is no, this is not a function because of right here. That 4 has both a 2 and a 5. And I noticed that here when it has more than one line that's going from there. So that tells me right there that that is not a function. Okay, 4, 5, and 6. Okay. So 4, 5, and 6, these are all what we would call continuous graphs. And continuous graphs are just graphs that are connected. Let's go ahead and write that, connected. We can call them connected graphs, but they're connected by lines or curves. Meaning, if you notice, we don't just have plotted points. It's actually a nice smooth line. It's just called a continuous if you were wondering what the difference would be. Now, continuous graphs are a little different because every place on this line is a solution. It's part of the function. So we can't just start listing points or coordinates because, well, we couldn't list them all. This is actually an infinitely many if we want to try to get in here and figure out what all these are. So if you remember back, this is where we talked about using inequalities to say, well, it starts here and it ends here. So for the domain, if I look, my domain starts here, and I'm going to draw a dashed line here instead of a solid. See, that's an open circle, so it doesn't actually go through it, but it goes up to it. So my domain started here at 1, 2, this would be -3, and it ended here at 1, 2, 3. So the X is in between there. All of this is connected in between those X values. So -3, it is solid, so less than or equal to X, which is less than 3. So really what this is saying is X is somewhere between -3 and 3. And we're going to do the same thing for Y. We start at the lowest point and we'll move up to the highest point. So the lowest point is 1, 2, 3, -4. And the highest point, 1, 2, 3, 4, 5. And Y is everything in between. So I'm going to start with the lowest, so -4. Now here we don't have open and closed circles. We just know it goes all the way to and touches that line. And that's going to include it. So it's going to be less than or equal to Y, which is less than or equal to 5. So Y is everything between -4 and 5, including -4 and 5. Now, is it a function or not a function? The answer is, well, yes, this is a function. So remember the vertical line test tells me that I would basically just hold my pencil up. Hard to do here to show you, but I'd hold my pencil up in a vertical format here. So I'm going to just get a different color here. So let's pretend like this is my pencil on a vertical line. And I'm going to slide it across, and I'm going to check to see, is there any place where if I'm sliding it across that I would touch the function more than once? And the answer here is no. I would touch the function always, but I would never touch it more than once at a time. So yes, this is a function. This passes the vertical line test. Okay, let's take a look at number 5. Domain, range, domain, well, domain is going left and right. And I notice I have an arrow that tells me that this is going to keep going to the left. And I have an arrow that tells me it's going to keep going to the right. So it's never going to start or stop for X. So this is where we would put all real numbers. And then we talk about the range. Well, the range is a little different. The range is bouncing in between. So here's my low point, here's my high point. My low point is -1, my high point is 2. So my range would be in between -1 and 2. I need to think about, is this a function? Again, I'm going to double check that vertical line test. If I was to pretend like this was like a pencil and I was holding it up and I was taking it across, would I ever at any point have that line going through the function twice? And the answer is no. So this is a function. This passes the vertical line test. All right, we're going to look at one more. It looks a little different. It kind of looks like a parabola, but it's sideways. So let's not get confused with that. That's not what we've been working on here lately. Domain and range. Now, domain is all X values. And the domain starts here, but it doesn't end. See how it's open? These arrows tell me it keeps going. So my domain starts at -2. And because it doesn't end, it looks a little different. It says my X is always going to be greater than or equal to -2. I look for my range, which is the very bottom and the very top. Well, here, my very bottom and my very top are arrows going up and arrows going down. Well, since it never starts and stops, this here would also be all real numbers. We're going to use our vertical line test, and I can see right off if I drew a line here, really pretty much anywhere through here, if I drew a vertical line, it's going to cross it twice. And that means that that X value has 2 outputs. So no, this is not a function. All right, so there is your recap of domain, range, and functions. Paying close attention to the difference in a table, a discrete graph, a mapping, and continuous or connected graphs.